Welcome back to the channel. In this video, we will look at the sine formula. So let's look at this triangle here. As you can see, it doesn't have a right angle. So this means we cannot use sine, cos or tan to calculate the lengths of sides or the sizes of angles. But we can use this sine formula. So what is the sine formula? Well, let's see. So let's start by calling that length there little a. And as you can see, little a is opposite the angle A. And the sine formula says that the length little a divided by the sine of the angle A is equal to the same thing with b. So we have length little b, and that is opposite the angle B. So here we have divided by sine of angle B. And in turn, that is equal to the length little c, which we can see is opposite the angle C, so divided by sine of angle C. And that is the sine formula. Now, in a separate video, I'll show you why the sine formula is true. I'll give you a proof of the formula. But in this video, we will simply look to see how to use the sine formula to calculate the lengths of sides and the sizes of angles. So let's start with this triangle. And here we know that that length is 7 centimeters, and we know these two angles here, 52 degrees and 58 degrees. Let's supposing we want to calculate the length x there. So we can use the sine formula to do this. And if you like, take a few seconds to try and write down the sine formula for this triangle. If you do it, you should get this. So 7 divided by the sine of the angle opposite that 7 centimeters, which is 52 degrees, is equal to, you see what it is? It will be x divided by the sine of the angle opposite x, sine 58 degrees. So now we get here and we need to find the value of x. What should we do? Well, we can cross multiply, or we can call that multiplying by sine 52 and sine 58. It's the same thing. When we do that, we get this line. And now we can look up sine 58 degrees on a calculator, and it's that. And multiplying those two figures together, we get this 5.936, etc. And now, to find the value of x, what should we do? Well, we need to divide both sides by sine 52 degrees. So we get this. And again, we can look up sine 52 degrees on a calculator. It's that. And doing that division on a calculator, we find that x is 7.533 centimeters, correct to 4 significant figures. Now let's look at another example. So we'll start with another triangle. Again, it has no right angle. Here we know two lengths, 7.9 centimeters and 5.6 centimeters. We also know an angle, here it's 68 degrees, and we want to find the angle theta. It's very common to use Greek letters for angles. So again, we'll write down the sine formula for this triangle. See if you can do it yourself before stop the video. Anyway, it's this. It will be 5.6 divided by sine theta there, which is opposite the 5.6, is equal to 7.9 divided by the sine of the opposite angle, which here is 68 degrees. And now, what shall we do? Well, we'll cross multiply, or multiply both sides by sine theta, sine 68 degrees, and we get this line. And now looking up sine 68 degrees on a calculator, we get that, and multiplying those figures together, we get this 5.192, etc. Now we can find sine theta by dividing both sides by 7.9. And we get this. And doing that division on a calculator, we get this 0.02. And now we need to find the angle theta. And to do it, put the 0.657244, etc. on the calculator screen and press the sine to the -1 key, or it could be arc sine key on your calculator. When you do that, you should get 41.09 degrees, correct to 4 significant figures. And that's the value of theta that we're trying to find. So now let's go on to another example. And here, again, we start with a triangle without a right angle. And we know a length 8 centimeters. And here we know two angles. One is 57 degrees and another is 48 degrees. And we want to find the length x now. Now what shall we do here? X is opposite the angle C, but we don't know the size of angle C. It's not given. So the first thing we need to do is to find the angle C. And how shall we do that? Well, I think you can see that the three angles of the triangle there add up to 180 degrees. So we can simply find angle C by taking 180 degrees minus the other two angles. So x is opposite that angle there. And now let's find the angle C. And as we said, it's 180 minus 57 minus 48, and that's 75 degrees. So now we've got angle C. So we can use the sine formula as before. So again, take a minute to write it down, stop the video if you wish. It will be good to do that. You should get 8 divided by sine of the angle opposite 8, so 48 degrees, is equal to x divided by sine of the angle opposite x, which is 75 degrees. And now, again, here we'll cross multiply, or multiply both sides by sine 48 degrees and sine 75 degrees, and we get this line. And doing that, looking up sine 75 degrees on a calculator, it's 0.965292, etc. And doing that multiplication on the calculator gives us 7.7274, etc. And now to get x, we need to divide both sides by sine 48 degrees. So we have this. And looking up sine 48 degrees on a calculator, it's that. And doing that division on a calculator will give us x to be 10.40 centimeters, correct to 4 significant figures. And now let's look at another example. Here we know two lengths, 10.9 centimeters and 12.5 centimeters. We also have an angle there, 67 degrees, and we need to find the size of the angle theta. So how shall we proceed here? Again, we notice that theta is opposite well, in this case, an unknown length, the length AC. So to find the value of theta, what we can do is to find the angle A, which is opposite length we know, 10.9. Once we have angle A, we can get angle theta, knowing that the three angles, A, theta, and 67 degrees, add up to 180 degrees. So let's start with the sine formula. And here, what will it be? See if you can write something down. What you should have is 10.9 divided by sine of angle A opposite the 10.9. And that's equal to 12.5 divided by sine of the opposite angle, 67 degrees. And now cross multiply or multiply both sides by sine A, sine 67 degrees, and we get this line. And now look up sine 67 degrees on a calculator, it's that, and do that multiplication again on the calculator, and we get this 10.0335. Now divide both sides by 12.5, so we just get sine A on its own there, and doing that division on a calculator gives us this 0.80268, etc. And now you remember that to find the angle A, we need to have this 0.80268, etc. on the calculator screen and press the sine to the -1 key, or it could be arc sine on your calculator. But when you do it, you should find that A is 53.3868 something degrees. But that's the angle A. We need the angle theta. So as you can see, the three angles there in the triangle add up to 180 degrees. So theta is simply going to be 180 minus 67 minus the angle A there, which we just found to be 53.3868 degrees. And doing that, we get theta is 59.61 degrees, correct to four significant figures. Now let's look at one last example. And here we have this triangle, again with no right angle. And we know two lengths, 9.2 centimeters and 12.1 centimeters. We also have an angle, 47 degrees. And we want to find that angle theta at the top there, angle C. So what should we do here? Well, we can just write down the sine formula as in the other examples. Again, stop the video if you wish and try and write it down yourself. But you should get 12.1 divided by sine of the angle opposite, which is sine theta, is equal to 9.2 divided by sine of the angle opposite, 47 degrees. And here we'll cross multiply as before, or multiply both sides by sine theta and sine 47 degrees. When we do that, we get this line. And looking up sine 47 degrees on a calculator, it's that. And doing that multiplication gives us this 8.849. And now to get sine theta on its own, divide both sides by 9.2, and we have this. And doing that division on a calculator, we get 0.961889, etc. And you remember here, again, to find the angle theta, we have the 0.961889 on a calculator, and we press the sine to the -1 key, or it could be arc sine key on your calculator. But when we do it, we should find that theta is 74.13, etc. degrees. But if you look at the triangle, theta is actually bigger than 90 degrees. So it looks as though something's wrong. Well, in fact, sine of 74.13 degrees, etc., is the same as sine of 180 degrees minus 71.4.13. And I have another video on this showing it's the sine, cosine, and tangent of angles that are bigger than 90 degrees. And so here, clearly, theta is bigger than 90 degrees. So the angle we want is, in fact, this 180 minus 74.13 degrees. And that is 105.9 degrees. So that's the answer in this case. Hopefully you understood that last example. As I say, you should go to the video where I discuss the sine, cos, and tan of angles bigger than 90 degrees, so obtuse angles. So that's it for this video. Thank you for watching. Please remember to hit the subscribe button. I hope you've enjoyed the video and learned something from it. And I have 2 websites on which you can obtain unlimited practice in solving the type of problems that we've looked at here with the sine formula. On one of the sites, you just practice each of the types of problems we've had in the video. Site, you do a short test, and answering 5 consecutive correct questions will complete the test successfully. So thank you very much, and I'll see you in another video.